All right, let's look at the second law of electrostatics. The second law of electrostatics is also called Coulomb's law. It states that the force of attraction between two charges is directly proportional to the product of the charges and inversely proportional to the square of their distance apart. Full stop. Given two charges Q1 and Q2, given two charges Q1 and Q2 separated by distance R, as shown below. You can now sketch this. Given two charges Q1 and Q2 separated by distance R as shown below, you can now sketch this. So given two charges Q1 and Q2 separated by distance R as shown below, then from Coulomb's law, F we said is directly proportional to the product of these two, that's Q1, Q2, or perhaps Q1 times Q2. Call this equation 1. Also, we said F is inversely proportional to, we said the inverse, so 1 all over, not just the inverse of their distance, but the inverse of the square of their distance. So it becomes R squared. Call this your second equation. So these two things here, if I combine equation 1 and 2, I will have that F is directly proportional to the product of the charges and inversely to the square of distance apart. Combine this as one equation, F, this times 1 gives you Q1, Q2 all over R squared. So I have this. So from Coulomb's law, F is equal to Q1, Q2 over R squared. All right. So what next? From here, we know that if I have a proportionality sign in sines, what do I do there? Take it off, replace it by what there? Equal to, and add what there? A constant. So in this case, I'll have that F is equal to K Q1 Q2 all over R squared. So F is equal to K Q1 Q2 over R squared. So change here to equal to, bring your constant. Where K is the constant of proportionality, and K is equal to 9 times 10 to the power 9. That's 9 giga. K is simply 9 giga. What's a unit? If I want to make K to be subject to the formula, that's K Q1 Q2 over R squared. Let's make K stand alone. This becomes all over 1. This times 1 is itself. So K Q1 Q2 is equal to this times this F R squared. To get K, divide here by Q1 Q2. Divide here by Q1 Q2. This cancels this. So K is equal to this one here first in Newton, distance of separation in meters. The distance is square, meter squared all over charge in Coulomb times charge in Coulomb. Coulomb times Coulomb is Coulomb squared. My unit becomes Newton meter squared per Coulomb squared. So it becomes this Newton meter squared per Coulomb squared. So that's your unit, please. Per Coulomb squared. Also, K is equal to an expression 1 over 4 pi E naught. Also, K is equal to an expression 1 over 4 pi E naught, where E naught is equal to the permittivity of free space. That's about 8.85 times 10 to the power minus 12 also. 10 to the power minus 12. Your unit is just the inverse. This is the inverse of K, so it becomes Coulomb squared per Newton per meter squared. Please, just put minus 2 here, so it becomes positive. Coulomb squared minus 1 per Newton minus 2 here per meter squared. So that's your unit for this man here. If this is true, that means that we said F is equal to K Q1 Q2 over R squared, but we just said K is equal to 1 all over 4 pi E naught. So it becomes this times Q1 Q2 over R squared. Please, this one here is K. If I combine this, it becomes equal to 1 times this is itself. So it becomes Q1 Q2 all over this and this 4 pi E naught R squared. This one here or this one here is the expression for Coulomb's law. So for Coulomb's law, F is equal to KQ1 Q2 over R squared or Q1 Q2 all over 4 pi E naught R squared. Both of them are the same thing. Both of them are the same thing. Example 1, please. If two charges 4 microcoulomb and 0.5 nanocoulomb. If two charges 4 microcoulomb and 0.4 nanocoulomb are 0.5 nanocoulomb are 15 cm apart. Comma, what is the force between them? What is the force between them? Please, question 1, please. The force between them, will it be an attraction or a repulsion? For that question there, the force between them, will it be an attraction or repulsion? It will be a repulsion. Why? Hold on. The charges were what and what? 4 micro. What again there? If I say 4 and I say positive 4, are they the same thing? If I say, is this 0.5? So, hold on. The idea is this. Both of them are what there? Positive. So, what do you expect there? A repulsion. All right. Solution, please. Task 1, list out given parameters, as I've always said. Number 1, the first charge, how many there? 4 micro is what? 4 times 10 to the power there? Minus 6 coulomb. The second, Q2, is what there? 0.5 nanocoulomb. What's a nano? Minus 9. Number 3, the distance between them, how many? R is equal to 15 cm. Convert to meter, multiply not dividing. Divided by how many? Did I get 500? 15 over 100 though. That's what there. Alright. So recall formula next. Recall that we said F is equal to K Q1 Q2 all over R squared. That's equal to, this one is a constant. So whether you're given or not, you know the value. That's what there. 9 times 10 to the power 9. So I have this. Into Q1, 4 times 10 to the power minus 6. Into Q2, 0.5 times 10 to the power minus 9. All over, distance apart, 0.15 squared. Please punch numerator only. What's your value? Please punch numerator only. What's your value? Please punch numerator only. What's your value? Please give me that again, please. 0.0225. Please confirm this is correct. This is why you should come with calculator to class. Some people just come, no calculator, nothing. See, if you think that punching calculator is easy, it's a lie. It's hard to punch calculator. That's why you come to class with calculator. When they punch, you make the mistake and they will show you how it's done. That's the idea. Please give me correct value. What do you have? Minus 5 all over this square gives you what there? 0.0225, right? Yeah, 0.225. Please divide this correctly. What's your value? Divide this correctly. What's your value? 8 times. So 8 times to the power minus 4. I'm getting force. What's your unit? It's in Newton. Force is in Newton. Don't add meter. It's in Newton. Stop there. Don't add meter. So the answer is this Newton, please. So it's easy. Just K, a constant, multiply Q1, multiply Q2, all over, square the distance. That's all. For your own is like the easiest we can do. This is in engineering. We've gone far for this. For engineering, you expect this in what is called the vector form. Vector form, you have that. It's no longer F, but nowadays it becomes F12 is equal to K, Q1, Q2 all over R12, this all square times unit vector of R12. Very interesting stuff like this. It's called the vector form. We finish this. This is vector form. Very interesting stuff like this. You need to watch it. Very interesting stuff. There you won't be doing, this one is too simple now. There you'll be doing I and J. You're seeing I and J component of the force. Very interesting stuff like this. But don't worry, let's look at something else. Example 2. Example 2. Find the force of attraction between alpha particle. Find the force of attraction between alpha particle and an electron, between alpha particle and an electron 20 cm apart. Between alpha particle and an electron 20 cm apart. All right, let's get this done, please. Please, for that question, please note this one somewhere. Note this one somewhere, please. I gave you this one before now, but please note this somewhere. The charge on an electron, E, we said is equal to 1.6 times 10 to the power minus 19 Coulomb. Please, for alpha particle, note that the charge on alpha particle is equal to twice the charge on an electron. Please note this thing, please. It's equal to twice the charge on an electron. I still owe you an answer. I'll give you. I've not forgotten. I should have told you before, but I'm ready. So let me finish. All right, so look up, please. So solution number 1, I'm giving, that's why they didn't give you a value for alpha particle. They expect you should know this thing here. All right, so number 1, I'm giving alpha particle, which is equal to 2E. Number 2, I'm giving electrons E, that's equal to 1.6 times 10 to the power minus 19 Coulomb. Number 3, I'm giving distance apart, R. How many, please? 20 cm. All right, so from here, 20 cm in meters becomes 20. Divide this by 100. That becomes 0.2 meters. So I know that F is equal to K. Now look up, please. It's no longer EE or Q1, Q2. It's now alpha particle. So let's say alpha particles plus multiplied by E. So it becomes this. So K, no longer Q1 and Q2, but now alpha and electrons all over R squared. The same concept. So this now becomes that F is equal to K. This one here is 2E, as we said. This one here is E all over 0.2 squared. This becomes, this value here is 9 times 10 to the power 9, that's k, into 2. E times e gives you what there? E squared. Please observe. K is this, 2 is this, e times e is e squared all over 0.2 squared gives you 0.04. It should be 0.04 now. Check, it should be 0.4. So that's equal to, this gives you 9 times 10 to the power 9 into 2 into, this value here is 1.6 times to the power minus 19 squared all over 0.04. Please look at numerator, punch it correctly. What have you got? Please confirm the answer, please. Punch numerator correctly. What do you have, please? All right. 4.6 times 10 to the power minus 28 all over 0.04. Final answer, please. 1.1. So 1.15, 15 approximately, times 10 to the power what? Minus 26 units Newton. So that's your answer. Newton, so that's your answer. Please check the question again, please. I said, example 3, whatever. It says, by assuming that a hydrogen atom consists of an electron of charge E minus and a proton of charge E plus, it says, show that the ratio of the electrostatic force to gravitational force is independent of distance of separation. Also find this value given that the mass of electron is this, the mass of proton is this, and the universal gravitational constant is this. All right, let's get this done, please. So first things first, look up, please. First things first, if you look at the question, it says show that the ratio of what to what. It says electrostatic force to what there? Gravitational force. In mathematical form, I am looking for ratio division of what to what. It says electrostatic to gravitational. So the first one comes as numerator. The second one comes as denominator. Ratio of electrostatic force to gravitational force. Let's see what this is. From Coulomb's law, from Coulomb's law, what do we know? We know that F is equal to K. Now hang on, please. They give us this as E and E. So it becomes no longer Q1, Q2, but E to the power minus for the electron, and then E to the power plus for the proton, all over R squared. So I have this. This is Coulomb's law. When we say gravitational force from your last semester work, this was who provided the law? Newton. Newton's law of gravitation. So it's called Newton's law of gravitation. From Newton's law of gravitation, it states that the force, Newton's law and Coulomb's law are the same thing. The difference is in mass and the constant. From Coulomb's law, it states that the force of attraction between two masses is directly proportional to the product of the masses, that's this of the electron and this of the proton, and inversely proportional to the square of their distance. When I take off my proportionality sign and put a constant, for this one here, the constant is what? G. G is called the constant of proportionality for Newton's law, also known as the universal gravitational constant. All right. These two, this is equal to K. Please, regardless of the minus and the plus, E is E. The minus just says is E for electrons. The plus just shows what there? E for protons. So K, E and E is E squared. Let's leave out the minus and plus, all over R squared. So hence, if I do F of E all over F of G, That will be equal to, in the very simplest form, it becomes electrostatic force, which is this. That's Ke squared over R squared. So it becomes this one here divided by, so it becomes divided by this one here, Fg, which is K, that's G, M of electrons, mass of electrons, M of P all over R squared. Work this out. This becomes equal to Ke squared over R squared. To divide fraction, change that to what's there? Times. Next up, invert. So if I invert it, this man comes up, this one goes down. It becomes R squared all over G M E M P. From here, obviously, this can cancel this. So that means Fe all over Fg is equal to this Ke squared all over G M E M P. We have successfully proven that it is independent of distance. Observe there's no arrow here. So we've shown that it is. So this is A part. It says show that it is independent of distance. You can see the distance will cancel out. So we've done the A part. The B part said we should now find the value of this ratio. And that's equal to K is 9 times 10 to the power 9 into E. We said E is a constant, 1.6 times 10 to the power minus 19 all squared, because it's E squared, so this squared, all over G. There. So here's G, 6.67 times 10 to the power minus 11 into ME. Mass of electron, that man there, 9.1 times 10 to the power minus 31 into mass of proton, this one here, 1.67 times 10 to the power minus 27. All right, so I have this. So that's now equal to, please give me only numerator. Only numerator. What's my answer? 2.3 minus 28 all over, give me the denominator please. What do I have? 1.01 minus what? Minus 67. Please help me confirm this is correct. Let's proceed. Confirm it's correct. Let's proceed. Nobody was also punching. Which of them? It's correct. Okay, do you know Tonko? Correct. All right, give me final answer, please. So Fe, hold on, all over Fg. Final answer 28 approximately times 10 to the power. Sorry? 39. Any units? No. Why? This is this man here in Newton, all over this man here in Newton. Newton cancels Newton. So 2.28 times 10 to the power 39. That's the value. That's what we have, please.